in this video, I'm going to show you how I go about repairing a leaking pipe in this customer's bathroom. Now, this is not a DIY budget fix. This is a professional fix, so the pipe will never leak again. Now, this pipe is on the central heating system where the pipe is connected onto a radiator. But this repair applies to any copper pipework in your house. So I'm going to show you step by step exactly what I did to repair this leaking joint, from isolating the boiler or the system, whether you need to drain it down or not. Now in this case, I didn't drain the system down. I created the airlock so I wouldn't need to drain the system, and I'll show you how you can go about doing that. And of course, what you need to look out for to make sure that you get that joint perfect and you don't get any leaks in the future. So hopefully by the time you've finished watching this video, you'll have a lot more knowledge on how to go fixing your leaking pipe so you don't get any problems. At the end of the video, I'm going to show you a whole lot of photos and videos which I've taken over maybe the last 10 years of various leaks which I found in customers' homes, from gas pipes to central heating pipes to just general water pipes which have been leaking underneath floors, behind cupboards, wherever they are leaking. So do stick around if you want to see some more leaks. Because leaks are quite a common thing, and this video lasted just a little bit longer than I was anticipating, I've made a second video out of a whole load of other leaks which I found in my local area which I have repaired. And I'll leave that linked in the cards above now. Now, if you need to repair a leaking radiator valve, or you're thinking about fitting some smart controls, and all the accompanying videos to this video, you'll find all those videos and a whole lot more linked in the description below. So do check those out. Right, now let's get on with repairing this leaking pipe. So let's take a look at this leaking pipework. You can see where all that paintwork is flaking off, and we've got all that green on the pipework, and the water is dripping down, which has made a bit of a stain on the floor, and of course it's rotting away the skirting board. Which joint is leaking? I've got no idea. It's a 15mm T, and one of the joints obviously didn't solder correctly, and now it's leaking. So how do you go about repairing this type of leak? It's actually pretty straightforward and doesn't take that long to do. You can see the radiator valve at the other end of the radiator is perfectly fine, so it's just this little bit of pipework which needs repairing. Now, to repair this leak, I'm not going to drain the whole system down. I don't need to, so there's no point in doing that. It's extra work and it'll make the job last 3 times as long. And I'm not in the business of dragging jobs out. Now, this system is being run by a combination boiler. Now, this is a Valiant Ecotech Pure. And the first thing I do is to turn off the heating. Remove the cover so I can get to the boiler connections. I'm then going to isolate the boiler by closing the flow and the return valves. Now, I don't have to do this, but if I do, I then won't need to drain as much water out of the system because pressure will remain in the boiler. But if there's any chance that the valves might leak when I close them, I definitely would not isolate the boiler. And there we go. I've now turned this valve a 1/4 of a turn, and you can see the screwdriver slot now goes across the valve. So the valve is now closed. I do exactly the same on the other valve. Just give it a little wiggle because it's a little stiff because it's not been turned for a long time. And there we go. Last little turn, and now it's fully closed. And now the return and the flow valves are both closed for the central heating, isolating the boiler. Whenever you're working on your central heating system, it's always a good idea to turn the power off to make sure that nothing is live on your system and nothing can suddenly start running. And there you go, the boiler is now off. Now, if you've got a traditional system where you've got that large hot water tank and loft tanks, I still wouldn't drain this system down. What I would do is I would bung up the loft tank. That does exactly the same thing as isolating the boiler. It creates an airlock so you can work on the system without having to drain the whole system down. And of course, if you want to know about how to go about bunging up your loft tank so you can work on your system without needing to drain it down, I made a video showing you the best way to go about doing that. So the next thing I'm going to do is to close both of the radiator valves on this radiator. So that's the thermostat now fully closed, and now I'm going to close the wheel head. Now this is really tight and I can't get it to turn. I could possibly use some adjustable spanners and grip the plastic, but then it might break, and I can tell this is the type of plastic that would just shatter if you put too much force on it. Now, depending on the radiator valve, the cap may be just pushed on, And you could use some long-nose pliers or maybe an adjustable spanner to try levering it off. But if it's not coming off, like in this case, it's actually screwed on from the top. There's a little cap on the top there. Pop off the cap, remove the screw, and then I can use my adjustable spanner to close the radiator valve. Now, if the system has been balanced to make it work more efficiently, this lock shield valve will be set a specific number of turns open to make the system work as efficiently as possible. So when you close this valve, you should count how many turns it takes to close the valve. Remember that. And then when you open the valve back up again, open it up the same amount of turns. That way the system will remain balanced. And of course, if you want to learn more about balancing your system, I've made a video all about that to help you balance your system and make it more efficient. And there we go, that valve is now fully closed. Now I want to drop the pressure in the system and create that airlock. Now this radiator is installed in a wet room, so it doesn't matter if I spill any water on the floor. You can see where the pipe's been leaking, we've already got that sticky inhibitor on the floor anyway. Now I'm not going to try using this drain valve. I know that's just going to be more effort than it's worth. It could end up taking a long time and making a bit of a mess. And if you want to know why, obviously check out my video on how to drain your system and why drain valves can be a bit of a nightmare. So I'm going to put my bowl here, and what I'm going to do is to undo the nut that's on the radiator valve, so releasing the pressure that way. And I've got my water vacuum ready to catch that water. So now I've loosened that nut and you can see the water is coming out, and it's going to keep on coming until the pressure in the system drops to zero. Now, if you've got a traditional system and you've bunged up the loft tank, we need to do exactly the same thing, just wait for the pressure to drop. And you can see I'm slowly loosening the nut, gradually letting more water out until all the pressure has gone. Now on this system, this is taking a bit of a long time, and I've still got water coming out several minutes later. So that probably means that there's some air trapped in the system, which is gradually expanding and pushing the water out. So what I'm going to do to get this pressure out and over and done with a bit more quickly, I'm going to loosen the nut off. I'm going to put a rag over the top of the pipe and the radiator valve. Then I'm going to pull the pipe off the radiator valve and put my vacuum straight on top of the pipe, sucking out that excess pressure. And you can use this method in any location around your system where you need to get rid of that pressure. But just bear in mind, if you cut through a pipe which has got pressure in it, water's going to be coming out of both ends of the pipe. Now in this situation, I've closed the radiator valve, so I'm only going to get water coming out of the pipe. And there we go, a little bit of water on the floor as I was expecting. I've now sucked up all that pressure, so there's no more water coming out. So now I have created an airlock. So the system is still completely full of water, even the radiator's upstairs. But no more water is coming out of the pipe, which is exactly what I wanted. Now this pipe is still completely full of water. You can see if I drop the pipe down, we get some water coming out. Now I'm going to cut this complete section of pipework out. Now there's a fitting here, and if I just cut the pipe on the other side, it's just going to make it look a whole lot neater. So I'm going to use my pipe slice to cut through this pipe, but there's a whole load of paint on there. And I don't want to bung my pipe slice up with all that paint. Now normally I would use my blowtorch and warm the paintwork up and scrape it off that way. But because it's full of water, that's not going to work. So instead I could use my grips and just wiggle them backwards and forwards and chip that paintwork off like this. Now I'm doing this really gently because I don't want to scratch the pipework. Now another method I readily use is a file. So I just gently file away the paintwork, and that way I don't damage the pipework underneath. I use my inspection mirror to check underneath to see if I still got paintwork on there, and I have. A little bit more filing underneath. Now I can pop on my pipe slice and cut through the pipe. Before I cut through the pipe, I've got to make sure I've got a push fit cap handy, just in case any more water starts coming out of that pipework. And there we go, cut through the pipe and pour the water into the bowl. And there we go, here's that leaking bit of pipework now removed. Now you can see there's a bit of tape on here. maybe they were trying to stop the leak with a bit of tape, but I can guarantee to you wrapping a bit of tape around some pipe will not stop a leak. So the next thing to do is just to clean off that little bit of pipe work and make sure I've got a nice ring of copper all the way around to solder a new coupling and pipework onto. Check again with my inspection mirror, and I've still got paintwork on the back of the pipe. Now I'm just pushing the pipe down to let any water run out that bit of pipe. Then I'm going to prop the pipe up so it's sloping upwards, and that hopefully is going to stop any more water from running out of the pipe. All the time it's pointing downwards, water may continuously keep running out of the pipe as it drains the system down. I need to get the rest of the paint off this bit of pipework, so I'm going to use my blowtorch to heat the pipe up, and then the paintwork will come off easily. I'm going to heat the pipework up until the paintwork starts to burn like this, and then I'm going to get my wire brush and give the pipe a good old scrubbing, and the paintwork will come off really nice and easily. And there we go, that looks a lot better now. Now I'm going to get some emery cloth and just finish off the bit of pipework, give it a scrub with that, and that's going to clean it up and polish it up nice and shiny, ready to be soldered onto. Now the pipework is nice and shiny all the way around. But I can see there's a line in the pipework on the front. Sometimes you get score marks which are in the pipework when the pipe is produced. Now, that's not a problem when it's new because that line will be nice and shiny. But now it's quite dark and it could cause a leak. So I'm going to file away that score mark, that kind of scratch which is in the pipework. We're not taking off a lot, just enough to remove that line. Last little polish, and I think I'm happy with that. Now I'm going to remove this old pipe clip because it's broken and replace it with a nice strong new one. Now the pipe is nice and secure, giving me a point to work from. Give it a quick tidy up with the old vacuum. Now I'm going to connect a new piece of pipe onto the old radiator valve. The valve is still in its original position. I've cleaned up inside the radiator valve, removing any old joining compound. Now put a new nut and a new olive on the bit of pipework. Now usually I use joining compound, but this time I'm going to use some PTFE tape. Now all we need to do is to wrap a couple of wires of PTFE tape around the olive. And just remember, it's the front of the olive which does all the sealing, not the back of the olive. So I'm going to be wrapping the PTFE tape around the front of the olive, the bit that touches up against the radiator valve. Because the PTFE tape squashes down, you don't have to wrap the PTFE tape perfectly around the pipe. So there we go, 4 or 5 winds, and that should be enough. I'm happy with the way that looks, so it's now ready to be put into the radiator valve. And of course, if you want to know more about compression fittings, I've made a video showing you how to use them, where to use them, and of course the different ways to join them together. Pop it into the radiator valve and then do up the nuts. You don't have to do it up crazy tight. You just got to nip it up so it's tight and then go just maybe half a turn more. And I guarantee that this will be 100% leak free. Now I can get some more tube, put it up against my new bit of pipework, get a pencil, mark where I need to cut the pipe, and then use a 15mm pipe slice to cut the pipe off on that pencil line. There we go, clip it on, and just twist it around. If you haven't seen a pipe slice before, you can buy these anywhere. Really easy to use. You just snap them onto the pipe and twist it around, and it cuts the pipe off perfectly. So there's my new bit of pipe work. So all I need to do is pop it in position and cut off the other pipe. So there you go. You can see it's a nice tight fit. Let's just test it with a coupling. That's fine. Now you'll find there's a little bit of movement in the fittings, and I want to make sure that I get this pipe straight and level with the rest of the pipe. So all I'm going to do is just pop another bit of pipe on top and check that the pipe is level all the way along with the rest of the pipe. Bearing in mind there will be a little gap because it's sat on top of a fitting. I can now mark this bit of pipe and cut it off. So there we go, pop on the pipe slice and cut it off on the pencil line. Clean it up with a bit of emery. Clean my other bit of pipework up, make sure that's nice and clean as well. Now here's the only problem I got with this bit of pipework. This pipework is straight and flat and level, and it goes through the wall, so there's no movement on it. Now if this pipe tips down slightly, water may start running out of it. because the system is completely full of water and it's just the airlock holding the water back. There's no water dripping out now, so I'm going to hope that no water starts running out. Now, if you're trying to solder your pipe like this and you've got water continuously dripping out of the pipe, the thing to do is to raise the pipe so it's an uphill slope to your fitting. And you may need to do the soldering really quickly. I'll sometimes use my water vacuum, suck the water out, solder the fitting before more water starts running out. Now, I use Everflux to do all my soldering. Now, be aware that this is an acid-based flux and you only need a little bit on the pipework. And there we go. I just smear a little bit around here. I always like to put a little bit in the fitting, although it's not recommended. If you use a non-acid flux, you may need to use a lot more flux. And then you may get it running down inside the pipework, which is why it's not recommended to put it inside fittings. But you can see I'm just putting a smear on this pipework, and that is all you need of this Everflux. What you don't want to be doing is putting a great big blob like that on the pipework. That's excess flux, could be running down inside the pipework. It's not going to burn away when you heat it up, and so then you're going to have acid flux just floating around your system, which obviously is not a good idea. So with any acid-based flux, use as little as possible. Having said that, other fluxes you might need more. And there we go, that pipe's ready, so pop it into the 15mm coupling. Now I need to add a fitting at the other end. Now I could use an elbow, but there's two problems with using an elbow at this point. One, I won't be able to drain this bit of pipework down if it's needed. And two, which is more important right now, if I fit an elbow, this bit of pipework will then become sealed. Now this is very important and it applies to any soldering that you may be doing. If I try soldering this elbow, the air inside the pipe will start to expand. It can't go along the pipe because the pipe and the rest of the system is full of water. And the expanding air can't go up the pipe into the radiator because the radiator valve is closed. Now what will happen if I solder any fitting on a sealed bit of pipe is that air will start to expand as the pipe heats up, and then the air can't escape, and so it goes out through the fitting, blowing out the solder which is in the joint, and of course that joint will then leak. And no one wants a leak. So there's several ways around this. In this situation, fitting the T and a drain valve then leaves the pipe open to the air so the expanding air can escape easily out through the drain valve. Another method I could use would be to remove the pipe from the radiator valve. That would leave the top of the pipe open. I could open up the radiator valve that I'm working on, drain all the water out of the radiator, and then open up the air vent at the top of the radiator, allowing the air to escape up into the radiator and out of the bleed valve. And another method I could use would be just to use a compression T fitting. But of course, you shouldn't use compression fittings in inaccessible places, like underneath floors. And plus, they look really DIY-ish and ugly. Now I've just fitted a drain valve into the T. Just consider how it's going to be used in the future. Are you easily going to be able to attach a hose pipe? If I point the drain valve straight down, it'll be really hard to attach a hose pipe. I could point it straight out, but I think I'm going to set it at 45 degrees. Now I'm going to get my rather well used heat mat and just tuck it in behind the pipework. Make sure everything is still pushed together and hasn't moved. And now I'm ready to solder this fitting up. Now I'm using some lead-free solder, and that's all I carry in my box because you mustn't use lead solder on pipes which are going to be used for drinking water. I want to quickly jump in here and introduce myself. My name's Mark Ballard and I've been a gas registered engineer for over 30 years. The aim of my channel is to help you with your gas boilers and your central heating. If you find this video at all useful, then please give me a little bit of feedback by clicking on the old thumbs up and subscribe. That will help others to find the video, and of course share it with anyone else who may be interested. If you visit my website, I've categorized all my videos and products and parts that I recommend so you can easily find what you're looking for. And if you fancy getting yourself a DIY t-shirt or maybe a mug, then check out the shop below. And I'd like to say a really big thank you to everybody who's bought me a cup of coffee and left me a donation in my Toolbox fund. It's really appreciated, and it does really help me to make more videos, which will hopefully help you. Now I'm gently going to start heating up the joint. I'm going to move the gun around so I don't concentrate the heat in one place. And you can see I'm not playing the flame directly on the mat. I'm playing the flame along the pipework so the heat can escape easily. Now I started to apply a little bit of solder, and then I decided to stop because I was concerned about some solder running off, running down the mat and then landing on the floor and melting into the plastic floor. And trust me, this does happen. And if that happens, you cannot fix it. So always take care of any type of floor. Now I've put an old towel underneath the heat mat, so if any solder runs off, it's going to go onto that old towel. Now I can continue with the soldering, and you'll see a couple of blobs of solder actually run off and run down the mat. And it's surprising, you don't need that much solder. I think it is 1 diameter equals the amount of solder you should need. There we are, look, put 2 diameters on there, and you can see the solder actually running off when I've melted it in. Now these fittings are called end feed fittings, and the solder will get drawn into the fitting through capillary action. And there we go, I think I'm happy with that fitting now. I let it cool down for a bit before I wipe the joint off with a damp cloth. Now it is really hard to see, but there is a ring of silver all the way around the top of the T. So I know it'll be a good solder joint. Now I'm hoping that no water has run down the pipe onto this fitting here. A 15mm coupling doesn't take long to heat up, and I'm able to start applying some solder to the new pipe. Now when I try adding it onto the old bit of pipe, you can see that's not heating up yet, and that's because there is a little bit of water in that old bit of pipe. Hopefully that little bit of water is going to boil away and escape through the open drain valve. I changed the angle of my torch slightly to heat up the pipe just a little bit more, and then you can see the solder starts to melt and it gets drawn into the fitting. And there you go, you can see that solder being drawn into the joint through capillary action, a little bit more on the other end, and there we go. I run the solder along the bottom of the pipe to knock off any large drips of solder. And there we go, that's the final fitting soldered up. Quick check with a mirror. Give it a wipe off with a damp cloth. It doesn't hurt to do a last check around, make sure that everything looks perfect. I can now refit the drain plug and screw that in and nip it up. Don't do drain valves crazy tight. It's a rubber washer and it just needs to be nipped up. Now everything is still isolated, and it'd be really nice to flush that little bit of pipework out, remove any bits of flux that might be in there, or possibly any loose bits of solder. So I can do that really easily. So I'm going to go back to the boiler, I'm going to open up the 2 valves, top up the system, and then I'm going to flush it through. So I use my adjustable spanner to open up both the valves. I just turn both the valves a quarter turn so the screw slot is now in line with the pipework. I'm now going to switch on the mains power and then see how much pressure we've got left in the system. The boiler's loading, and you can see the pressure has dropped. We got 0.4 of a bar of pressure. Open up the filling loop and top up the boiler. I'm now going to go back to the radiator and open up the drain valve. That's going to let water wash through the pipe and remove anything unwanted in the pipe. Once I'm happy I've washed enough water through, I just close the valve again and nip it up. Just need to bleed the radiator and let any air out of it. And there we go, that bit of pipework is definitely never going to leak again. I've now refitted the radiator cap, I've opened the valve up the correct amount of turns, run the heating briefly to make sure everything is getting hot. So there we go, that's how I go about repairing a leaking fitting on copper pipework. Right, now let's take a look at a few more leaks. And don't forget, I have made a second video all about leaks and how I went about fixing them. So maybe take a look at that video as well. Right, so let's take a look at this leak here. Now this is a hot water pipe fed from a combination boiler. And the elbow, which goes through the wall, has started leaking. Now you can see that hot water pipe there. We've got a new bit of pipework which has been soldered onto the original pipework which goes through the wall. The easiest way to fix this, like before, is to cut the pipe a bit lower down, like I have here. I then cut the pipe inside the airing cupboard, and then hopefully I can then pull a piece of pipe out, which I can. And there we go, there's that elbow which has started leaking. So once again, the best way to go about fixing this is just to replace the whole lot. Cut the pipework further back and don't mess around with the joint. Just put a new bit of pipework in with a new elbow, much quicker, job done. Here is a leaking mains water pipe which is feeding a combination boiler. You can see all that green there again, and I was servicing the boiler, I saw the leak, pointed it out to the customer, and they didn't even realise the pipework was leaking, although there were drip marks on the floor. And you can clearly see the drip of water coming off this bit of pipework. So once again, there's no point in trying to repair the joint. The joint is going to have lots of bits of scale in it, so even if you manage to solder it up, there's a good chance it might leak again. So I look for the easiest place to disconnect the pipework. And here we have a compression fitting at one end, so I can undo that, cut through the pipe just above it, and then I can replace that bit of pipework. And there it is. There's that leaking joint, gone now, new bit of pipework, definitely won't leak again. Now here is a leaking pump valve, and this pump is fitted above a boiler. And if this is left, the boiler will slowly rust away, and then the boiler will need to be repaired or condemned, because this is a much older boiler and parts would definitely be hard to get hold of. Now it's actually the gland nut on top here which is leaking, so it's a pretty straightforward fix. Grease up the gland nut, do up the nut nice and tightly, wind the valve in and out several times, check for leaks, and there we go, that valve is now fixed. Now this is a leak I found underneath the floor, and you can see there is water spraying out through this steel pipe. Thankfully I don't see this pipe work very much, but it is still around, and if you're a plumber you should definitely watch out for it because it's a bit of a nightmare. Now I think it might have been during the war or after war there was a copper shortage, and so what they did was they copper coated steel pipework, because you can see copper fittings which have been soldered onto the steel pipework, which is impossible. But now the copper has eroded away over many years, leaving just the steel. And like I said, you can't solder onto steel, so you can only use compression fittings on it. But the best thing to do is to get rid of it altogether. Here's some more copper coated steel pipework which has started leaking. Now this is a bit of gas steel pipework. It was set in concrete. The lime in the concrete eats away the steel, so the leak wasn't detected until gas started seeping out through the concrete. All pipework set in concrete and screed floors must be protected, which obviously this one wasn't. And finally, here's a bit of mains water lead pipework, and you can see it started leaking, spraying water out underneath the floor. And the homeowner finally had a leak because they started getting really high water bills. Right, that's about it then. So I do hope this video has been helpful. If you want to watch my video on how to repair more leaks, then you can click on the link just there. If you want to know how to repair that leaking radiator valve, click on that link just there. And of course, as usual, please give me a thumbs up, click on subscribe, share it with anyone else who may have a leaking pipe. And of course, a cup of coffee is always appreciated in my toolbox fund. Bye for now, and I hope to see you in the next video.